Question number 3D is we have to again make sure that we separate out the outside vertical changes with the inside horizontal changes. So I'm going to start with my change in y. My change in y is going to be, firstly, it's going to be a vertical expansion by 2. And secondly, it's going to be a vertical shift down 5. Okay, so that represents my vertical changes. Then I go on to the inside for my horizontal changes. Now remembering that everything works backwards here. So for my change in x, my notation is going to be 1/3 negative of 3x plus 2, and we need to have some brackets in there like that. Okay, and so when I undo this, I'm going to unpack it so that I can solve for the other x. So undoing this, I end up with times 3, and really this negative is going to be on that 3. So I'm going to do this in steps. So I end up with 3x plus 2. Solving this, negative 3x minus 2, and then divide that all by 3, and I end up with that transformation. Okay, so this represents my description. So the first thing that's going to happen here is going to be a horizontal expansion by 3. Secondly, it's going to be a horizontal flip, and those can be interchanged. It's a horizontal shift of minus 2 or left 2, and then lastly it's a horizontal compression of 1/3. Okay, so that's one way we can do it. Now some people like to use what we call the factored form. So I'm going to rewrite this expression in factored form. So this is the first time I'm kind of talking about the factored form, but the factored form is perfectly valid. It's just not as flexible as being able to undo, and it also doesn't describe the mathematics that's going on of undoing when we do, because we're going backwards through the function machine. But I can rewrite this expression as, I can factor the 3 out, so I end up with negative 3x, and that becomes 2/3 like that, and then we have our 1/3 on the outside. And I can just multiply that 1/3 in. So I end up with negative x minus 2/3. And this represents my notation, but this is my notation in factored form. And in factored form, when we do, I'm just going to write this down. This is a factored form. I'm going to separate this out. When the notation is written in factored form, it's always a compression, expansion, and flip first. So in this case here, I'm going to horizontally flip, and then the shift is going to now be to the right. It's a horizontal shift to the right and 2/3. And notice that in this expression here, the way I did first, we have an expansion by 3, a compression by 3, and that's why there's no expansion or compression that ends up on this function, because they cancel each other out. Okay, there's still my horizontal flip, and the horizontal shift has been flipped around, so it's going to the right now, and it's been compressed because of the order that it was done. Okay, so it's now just a shift of plus 2/3.